Let's find the moment of inertia of this rod about the z-axis passing through point O, using the known moment of inertia about a z-axis passing through the center of mass, which is in the middle of the rod. So these axes are parallel, so we can use the parallel axes theorem to find the moment of inertia about point O, using the moment of inertia about the center of mass. And we simply add the mass multiplied by the squared distance between those two axes. So we've derived this term previously, and we add the mass by the length on 2 squared. And if you do the algebra, you'll get ml squared on 3. Let's find the moment of inertia of this rod about a z-axis passing through point A. Well, we know the moment of inertia of the rod about a z-axis passing through the center of mass. And because these axes are parallel, we can use the parallel axes theorem. Where the squared distance is from the z-axis passing through the center of mass to the z-axis through A, which can be obtained using Pythagoras' theorem. So we previously derived the moment of inertia about the center of mass, and d squared is as follows. In doing the algebra, we obtain the following result.